here's a preview of the circuit I'm going to show you how to build and program. What we're actually going to do is control this LED using some Python code so it turns on and off. We're merging what we do in the physical world with what we do in the digital world. This project is going to use your breadboard and T-cobbler as usual, and we're also going to use one 470 ohm resistor, a red LED, and some wire. Go ahead and position your breadboard so that row 1 is at the top. I know you can't see it because it's underneath the cobbler, but we know that it's up there. If you haven't already positioned your cobbler, you want to put it so that the 3v3 pin is in row 3 on the left in the top corner there. And once you have that set to go, we're going to go ahead and start attaching wires. So the first thing we're going to do is we're actually going to connect the wire to a GPIO pin. And we're actually going to connect it to pin 17. So look for pin 17, and this wire is going to run from pin 17 on the T-cobbler, which is in row 8. And then it's going to run on down to row 31. So although other projects we've connected something like 3.3 volt to the positive rail, we're actually not doing that in this project. We're just connecting one of the GPIO pins down to another row on the breadboard. Next up, we're going to grab that resistor and we're going to span the ravine. So there's a 470 ohm resistor and it's in row 31, just spanning the ravine. And the next step is we're going to drop in an LED, and we want the anode, the longer leg, in the same row as the resistor. So that'll be in row 31, and the shorter leg, the cathode, will be in row 30. Now it doesn't matter which exact dot you use. I like to actually just set it so that it's pretty much straight up and down. As you can see as I pull this to the side, we've got the anode in row 31 and the cathode in row 30. You can put it at an angle if you like. Sometimes that gives a little bit of a unique flavor to the circuit. So if you look and pull this back, I've got it sort of a 45-degree slant there. I'm going to leave it like that. Next I'm going to grab a wire here. I'm going to put this connecting our cathode, the shorter leg, in row 30 over to the negative rail. And then I'm going to go ahead and connect one more wire now coming off the negative rail and headed to ground. This is actually going to be row 19. And now we have our circuit ready to begin programming. So the path of the actual current here comes off of pin 17, travels down this wire, then jumps into row 31 here, travels through this resistor, crosses the ravine, now it's on the other side of row 31, goes up the LED, comes back down into row 30, which then connects back to the negative rail, which shoots up here and brings us back to ground. So we have a complete path here, and whenever we toggle pin 17 on or off, we'll actually see that LED light up or turn off. So let's go ahead and get started programming. So go ahead and boot your Pi. Make sure that you have the T-cobbler plugged into the GPIO ribbon cable. You have your USB mouse and keyboard connected, your video cable connected, and your micro SD card inserted with your operating system installed. Add your power cord and it'll boot up. Remember that your username is Pi and your password is Raspberry. Use Start X to launch the desktop. Also remember to shut down your Pi before making changes to your circuit. You can use the shutdown icon on the desktop or use sudo halt from LAX Terminal. So here I am on the desktop of the Pi. I'm going to go over to idle 3 and open up Python. Here I am, I'm inside of the Python shell, and although this is a really neat place where we can do some interesting stuff, we're actually going to need to open a new window. So we're going to go File, New Window, and get ourselves a blank window here, because we're going to write and save a program here. It'll say Untitled at the top, and we're going to go ahead and fix that right away. I'm going to say File, Save As, and we're going to give our new program a name. So I'm going to name this Blink 17, because we're going to use pin 17, and we're going to make an LED blink. So I'm just going to try to pick the most descriptive name I can think of. And hit Save, and it goes from Untitled to telling me that the name is blink17.py. So let's jump into the code here. Import rpi.gpio. Capitalization does matter here. So R and P should be capital, I should be lowercase, and then dot all capital GPIO. As GPIO, this is actually sort of an abbreviation. So when I call GPIO, it's actually substituting that in for rpi.gpio, which is a module that allows us to talk to the input-output pins. So this is actually a really useful part of our program. And then I'm also going to do import time. Now, some of you may be aware that we can actually do this all on one line. I can do import rpi.gpio as GPIO, comma, time, but for the sake of helping us sort of understand that there are two modules in play here, I put them on two separate lines to help familiarize you with that. So time is actually going to give us the ability to do time-related tasks inside of our program, such as waiting for a second, which will be really important to making the LED blink and then turn off for a second. I'm going to do GPIO.setMode, and we're going to choose GPIO.BCM. So this is the Broadcom numbering, which matches the T-cobbler. However, there's GPIO.board, which is actually a strict numbering where it goes 1, 2, 3, 4, etc. in order. If you look at your T-cobbler, you'll notice that the numbers do not progress in a 1, 2, 3, 4 kind of order. So to match the T-cobbler, we use set mode as GPIO.BCM. Next up, we're going to name a variable for our LED. So LED1 refers to our LED. It might seem strange to use LED1 whenever there's only one LED in the project, but as we add additional LEDs, they would be LED2, LED3, and so on down the line. And so calling this one LED1 now saves me the trouble of having to rewrite this code whenever we expand this project later. Now you might be thinking, well, I thought, a lot of times with programming we start counting at 0. Well, that may be true for the programming language, but as humans it is helpful that we have LED1 as LED1. If I called it LED0, it just kind of makes things a little cluttered for me to think like, how many LEDs are in this project? And then I'm looking at, let's say I have a variable LED4. It's like, oh, I have 4 LEDs. Well, if we start counting at 0, we'd really have 5. So it's easier for humans, since variables don't mean anything but what they mean to us, and it doesn't affect the program. It's easier just to call it LED1. So LED1 we're going to set to 17, which is the pin that we connected the LED to with our breadboard. Next up, I need to actually set that LED as an output pin. So we do GPIO.setup, and then inside of these parentheses we put the variable LED1, GPIO.out. So whenever I put LED1 in this line here, it's actually substituting the number 17. I could actually write directly 17 instead of LED1, but then it makes it harder to understand what this code is doing, and suppose I were to relocate the wire from 17 to, let's say, pin 22, all I would need to do is change this variable, and all other instances would then match the change. So it's actually always advantageous to use variables. So now that I've got that in place, that's going to give us the ability to use that pin as an output. That means that we can turn it on and off with the numbers 1 and 0, 1 for on, 0 for off. Think of it as high and low, high being the 3.3 volts of voltage, low being 0. And actually we can use 1 and 0, or we can use true and false, and I'll show you both in this video. So now that I've got that set up, we need to actually tell it to turn on this LED. So I do GPIO.output, and then I say LED1, and then 1 is what I'm going to use first to show you that 1 corresponds with on, and then I'm going to say time.sleep, and I'm going to wait 1 second. And that goes back to using the import time module that we wrote at the top. I do GPIO.output, LED1, 0, this is turning the LED off. I do time.sleep 1 second again. Now it might seem strange that after the LED is off, I'm asking it to wait another second. You'd think our program's pretty much finished, and it is, but I actually am putting that in place because having that extra pause is going to be useful whenever we go to repeat this block of code for multiple blinks. So it might not make a whole lot of sense why we have it waiting whenever the light is off and the program is over, but it makes sense as we go to expand this project in the near future. So I want to make sure that I save, because if I'm not saving this before I go to run it, it's going to run on the last save point, which was whenever I just opened a blank window. So it's important that you always hit File, Save. I didn't want to do a keyboard shortcut since you can't see my keyboard. So I went File, Save to make it obvious. And then I'm going to go ahead and minimize this. And we're going to open up LX Terminal. Now there's multiple ways to get to LX Terminal. You can do it from the Start menu over here. But I just figured I'd minimize and point at the icon on the desktop. There it is, LX Terminal. Open that up. This should look very familiar to the command line you see when you booted your Pi. And it actually has pretty much the same functionality on the commands you type in here. So if I type in ls, that stands for list, and it should be lowercase ls, and I can see what's in my folder here. and blink17.py is in that folder, as well as the ones in blue, such as desktop, that's referring to another folder, and I can actually change directory with cd desktop, and I can go into the desktop folder. If I say list in here, I see all of the actual shortcuts on the desktop, but I don't need that, so I'm just going to go back to the main folder there, and again, ls, we can see that blink.py is in here. I'm just go ahead and resize my window just a little bit because it actually was kind of hanging over the side, and as I continue down, it's going to scroll weird if I didn't enlarge it. So I've enlarged the window so that it scrolls properly, and now I'm ready to go ahead and run my program. So I put in sudo python 3 blink17.py. Now you can actually just put B and hit tab and it's going to autocomplete. There's only one thing in this folder marked with B, so if any of you want to use that shortcut, you're welcome to do so, or you can type it out longhand. So sudo stands for superuser do, and you must use this every time you run something that uses the input-output pins, because it requires that you have the maximum privileges of the Pi. We call it superuser because you have full privileges, and actually it's funny because sudo is something that we aren't used to having in a Windows computer, which many of us use for our daily usage, and it's very common in a Linux computer. In fact, it's extremely vital to a Linux computer. So it's sort of a change in the way you're used to using a computer, but it will become very familiar to you in time. So when I run this line, we're going to go ahead and look over at the circuit. We should see the LED turn on and then turn off after 1 second. So let's take a look. So as you saw, the LED did blink. So I'm going to run this code a second time, and there's a really neat shortcut. You can just hit the up arrow and recall the last line that you just had, and I'm going to run this code again. So just hit enter to run it, and we're going to see the light blink again. There's a reason why I'm doing this twice. Okay, now let's look back at LAX Terminal. See how I got this warning that says, hey, this channel's already in use. That's actually, well, it's not that it's a bad sign, but it's not ideal. We left something out of this program that would actually keep that warning from appearing, and I'm going to show you how to do this so that you don't have that warning every single time you run a program in the future. It's real simple. All I do is I go back to the program and I put the phrase GPIO.cleanup at the end of this program. And what this does is it actually returns all the pins back to their default state. The reason why we got that message the second time we ran the program, and not the first time, was that the first time the program ran, pin 17 hadn't been assigned as an output. After that program finished, pin 17 was still assigned as an output, and then we ran a program that tried to do the same thing again. And so it said, hey, this channel's already in use. But if we use cleanup, it'll actually turn that pin back to its default state, and then when we run the program multiple times, it won't give us that warning message. So we're going to go ahead and say file save, and again, you can use the keyboard shortcut. I just like to make sure that you see me do it, since I'm on video and you aren't seeing my keyboard. And I'm going to go ahead and run that code again. Now, I'm just using the shortcut, just push up and it'll recall the last line, and I run the code, and lo and behold, I get the same channel's already in use warning another time. Now that might seem strange. Hey, wait a second, didn't we fix it? Yeah, we fixed it, but the last time this code ran, it wasn't fixed. So now that I've run the code with the fix, I run the program again, this time, I run it, no warning message. So that's what it should work like, now that we've fixed it. Okay, so we fixed the code so that we don't get a warning message, and we've got it so it blinks one time. This is a good start. But we can make this code a little more user-friendly. We have some other ways to refer to turn the LED on and off. Instead of 1 and 0, I'm going to switch it to true and false. And you'll notice that they actually are capitalized, first letter's capitalized. It's important that you use the right capitalization. I'm doing save again here. And true is on and false is off. And now that I've saved it, I'm just going to head back to LAX Terminal and use the shortcut here, and I'm going to run it again. So I run it, and sure enough, the LED turns on, and then turns right back off. True and false is easily substituted for 1 and 0 whenever toggling a pin on and off. There are times where you may want to use 1 and 0, times where you may want to use true and false. Either way is acceptable. I also want to show you that we can actually extend this program. We're going to highlight these 4 lines and copy them and paste them so that we can get 2 blinks of the LED. So that's why I told you we had that second time.sleep. Okay? So now that I've doubled the code here, I'm going to say file save. And now I should get 2 blinks. Back to LAX Terminal, run the code. Alright, so we got our 2 blinks. fine and good, but what if I wanted to blink 10 times, right? Wouldn't this get really cumbersome, just keep cutting and pasting this code, and it would make it difficult to understand? That's where there's something very important called a loop. And a loop is a great way to actually make things more efficient. So instead of having these, 8 lines to do something as simple as blink the LED twice, let's go back and knock this back down to the original 4 lines, okay? So I've just deleted what we just pasted in there. So what I'm going to do is create a loop. We're going to use a for loop, and it looks like this. For I in range 0, 5. Now I want to stress that this actually has only 5 passes through this loop for value 0, 1, 2, 3, and 4. That's how it works when we say for range 0, 5, is it uses everything but the last value. And so this is a quick way, since we're starting with 0, right, and the last value is 5, counting the 0 place, I know that there's 5 values, because it doesn't use the last value. It's really kind of intuitive in a nice way. So anyways, so what I have here is this for loop, and then I'm going to go ahead and indent these 4 lines underneath and highlight them and just hit tab. And these 4 lines indented and located under the for loop, notice that colon above them, that's the loop. It's going to repeat those 4 lines 5 times, and then it's going to finish that loop and go back to the non-indented code, which is GPIO.cleanup, which is basically the last step of the code to set everything back to the default state. So let's go ahead and save this and see how this works. Again, just recall the last line, use the up arrow, and it'll pull back up sudo python3 blink17.py, and hit enter. As expected, we got 5 blinks. That's a good sign. That's exactly what we're looking for. So let's go back to the code here, and I wanted to show you that you can modify this as much as you'd like. If you want to change this so that it's going to repeat 10 times, just replace 5 with 10. And if you want to replace it with 100, you can do that too. Anything you want to imagine, it's possible. Now, there's another kind of loop I just want to show you briefly here, and this is actually going to be done really sloppy, is I'm going to put while true. This is actually going to be an infinite loop, that there is nothing that will break this loop, because there's no conditional. It just says while true, and there's no type of variable involved or conditional that would actually break this loop. But I wanted to show you an infinite loop for a very specific reason, is that in some cases you might make a program that gets locked into something silly like this, where the conditional is never met and it keeps repeating a block of code until you interrupt it with your keyboard. And so you want to know the term infinite loop and avoid it unless it has some kind of advantage to you. There will be programs we write that have an infinite loop, but actually have a keyboard interrupt and GPIO.cleanup capability, so that it's okay that we have that. But in this case, I don't have anything other than just the standard keyboard interrupt, which will not clean up the pins when I run this. So this is actually kind of sloppy, but I'm going to save it anyways and show it to you, because I just want to show you how this works in case you ever trap yourself in a program. So sudo python3 blink17.py, hit enter, let's look over at our circuit, and it's blinking away, which is exactly what we'd expect it to do, but this will never stop. It'll just keep going, keep going, keep going, and the way I interrupt this is I hit on my keyboard Control Z. So I have you looking at the circuit here. I'm actually going to try to time this to do this whenever the LED is lit, because it's literally going to quit the program abruptly, and it's not going to turn off that pin or clean up that pin using GPIO.cleanup. So I could actually force it to keep the LED on. So let's see if I can pull this off. Ready? Alright, so I missed. And that's going to happen sometimes. Let me try one more time. I'm going to see if I can catch it while the LED is on. Okay, I got it that time. So I did the keyboard interrupt, and you can see the LED is stuck on. And it's important that you know that Control Z is your way to interrupt your program and get out of it in the event that you have something that's not running properly. Or if you just have something where you're like, I'm going to make this one an infinite loop, and I'll keyboard interrupt my way out of it because I know how to do that. So hopefully this project got you familiar with a little bit of code, a little bit about infinite loops, even though I'm not recommending them, I'm just telling you that they exist. And we will actually use an infinite loop in some of our games, so they continue playing infinitely until the user is ready to quit. But what we'll actually build in is an interrupt that will break that loop using the keyboard interrupt and still clean up the pins so that we won't have this problem where the LED is just stuck on. I hope you enjoyed this project and thank you for watching.